In this video, I'm going to go over all the time value of money problems from Chapter 5. Now, the first that I'm going to look at is future value. So if you notice down here that number of tabs, I'm going to recolor the tabs. There's a number of tabs here that we're going to go through all of these tabs, and there's quite a number of tabs we're going to do. I'm just going to highlight them by different colors so you can tell that there's a number of tabs that we're going to work. Okay, I'm going to stop there. So to get tabs, you just click on the tabs, and if you have a very small screen, you can use to switch between. So the first tab we're working on is future value. So we have the first problem here of $100 for 3 years at 10%. In Excel, negative amount because that's a negative to your cash. You invest our $100 in your cash, so we usually denote that negative amount. I have a little note here saying use the function formula in Excel. So I go formulas function, I'm going to search for F, and then double click on that, the rate. So we have rate, so I'm going to click on that, and per for this. Oops, back there. And per. The present value is there. So when I hit done, I answer. Now we can again for problem 2 is going to be the same problem but just different numbers. We put in our rate, and per, and our value. We get 289 is the thing. We invest $50 5%, we end up with 289. Now, so all 4 of these problems are the same problem. So we'll do our rate, per, then per. Done. Also, since this is set up, I and paste it to quick, and it's going to put the same layout. But moving on to problem 5, we now have a little bit of a wrinkle. We send it, so the frequency, or M, is 2. Calculate this, use the future value function, multiplied by the frequency. And when we put in the N per, multiplied by the frequency. The present value is going to be hit done, and this will calculate again to calculate. We just count when we divide by the frequency, and the N per, which is the year frequency in the formula, and it's just the value. Done. Okay, so now, and a new payment. Again, problem. We use the same future value, our rate, our present payment. So for the payment, let's try to put the symbol, it's easier, and we hit the rate, future value, per 5, and payment. So it's the only difference rather than the present value. Is that it's $5? Yeah, it's $1,600. It makes sense. Rather. Now, if we wanted to calculate the deposits needed to accumulate to a future sum, we would have to use what's called here, I made a note, you can use the payment in Excel. So we're going to type in T, payment. And it makes sense because we're trying to calculate the annuity payment. We have the rate, and per is the years, and now we put in the future value. So this would tell I would need, and it shows as a net flow because it's a payment, and that's fine. Just note that in the homework manager, you would positive number, not a negative. Also adjust the formula if you wanted to say multiply by -1, again to show as, because either way this is a cash outflow. If we do this again, payment, rate, and per, future value. And I can say, this is how it expresses payment is going to take away cash. When you enter it into the homework manager, it does want a positive number, so you can just multiply by 1. Frequencies, and you can see by multiplying the annual rate. Look at that a little bit more when we do the home and loan. Okay, so let's do present value. So in present value, let me make this bigger, going in the opposite direction. So we're going to use the PV function. PV, search for PV. And how to formula builder, I go to function and I search for function. And it's better to use the formula builder when you first start rather than the actual formula automatically. So here we're going to select our rate, our N per, future value. Our present value, did it the wrong. Make sure you're where you want to calculate. Present value, rate, N per, and then future. Get done. And it expresses as, again, Excel always expresses negative, but we want really to show it as a positive and multiply it by -1. All the same, so I can easily copy these over times to show present value and value. -1 at the end. So that's just a single value. Smaller then what to test this when you're in future value, be smaller than when you're in future value. This will be larger than your starting point, larger than your present value. It's 1,400. But in present value, smaller amounts because we're looking at the terms. So it's a way to calculate. Now, what if there's a frequency? So if we do semi-compounding here, it's still going to use the present value function, annual rate here, by the, and when we do error, it's going to multiply by the frequency. Same thing, and then we're going to put in value, and this will tell us what it is. And I'm going to just say -1 to get the positive number. So we do that again. I take the annual rate, see, multiply by the frequency, and then put in the future value rate, -1, to make it positive. Now, what if we have an annuity? So, what is the present value of $200 here for 3 years at a 10% rate? So I'm going to use the present value, but I'm going to use here our N per, but I'm going to put that in the payment. Tell me that I would, the accumulation would be, and again, if you wanted to in the payment, if you want this to come out to, so what's the present going to receive dollars a year for 3 years? Rate, discounting at a 10%, the value of dollars is $2,600. Today's value is $2,900 because of the discounting effect of, say, this is rate. I'm going to do this problem again, our rate number of years, and then our annuity -1, so we get the result. So even though this would be $300 for 3 years, and it's only $800 today. Be an annual payment to repay a loan. So say we bought a 12% rate, what would be payment? Now to use the payment function. So we're going to use the payment function. Have our rate per and our value. So this would be, and we were going to do years at 10%. We use the same rate and then see here that if you're going to be years instead of 4, the more per year. Okay. So let's see functions in your return. It's a little bit bigger. That's what we're doing here. So here's a basic problem at spent rate of years. What would be the payments thousand? So formula as sure $100 a year to get to 30,000. Pretty simple. And this is an annual to do to equal 20 million. So let me actually weigh these answers here. Okay. So how do we what the payment if we wanted it in 50 years? So you retire, say you retire at 72. That's a 50 years of work. Annual rate of 10% for the market and 20 million. How much would you have to save in? So again, we use our payment function, N per of the rate, and then N per is number of years, and the future value is going to be. So we're going to save 17,000. Stock market returns an average of 12%. So say we're optimistic and we figure 12%, put in the variables, and then we have to save $8,000. 2% difference in return means that we have to save a year to get 20 million. What if we're looking at weekly deposit, money back every week? How much money every 4? So we're going to again use that. Now our rate to divide by frequency, and then we're going to take just 50 years and a multiple frequency, and our future value is 20. So that means we'd have $2 a year to get to that $262 a week. And I should change this. This should be weekly payment. Weekly annuity payment. So again, how do we calculate the difference if it's actually 12%? So again, payment divided by 52. N per 2, and our future value is 20. So there'll only be 100 a week to save. So it's different. You know, a mix of bonds, and so it might only be an 8% return, which means you'll have to save 5 to get that same rate. The return, annualized rate of return on your portfolio makes a big difference to a large future sum. Now, also, let's look at things you could calculate this with. Going to be, let me show you how to take out these answers here. Okay, so a loan. So we want to do an end here, which we did in a problem previously on the present value. A similar problem with that 12%. Again, if we want to use the payment function, rate, N per, and then we have our present value because it's, and I'm just going to put a negative, and then I get $1,890 would be the annual loan payment. But let's look at car loan, $26,000 at a paying monthly. How much loan payment be for a car? The 5%, N per is going to be multiplied by the frequency. We're going to put in our present value. One negative here, since the value is 26, a positive number, so we can calculate it. Now we get $490 per day in a car loan. You had a 5% rate monthly payment. Now let's look at home. So you're going to buy financing for a home is $420 rate. And I always stop to make sure it's not. Actually, it's a 3.5%. It's important that when you open it, I usually like to open up these 3 years at a frequency of 12. I like to have this form up really as I'm going through. Okay. So let's calculate this. Payment rate is going to be 3% divided by, which is 12, and per will be the number of years multiplied by the frequency, and the present value, put a negative sign to note the cash outflow. So our monthly payment would be $1,912.93 on that. Okay. Let's move in. So here's an annuity due. These are similar that we did in future value, but these are annuity due format. So we want to calculate the start here. So how do we do that? It's saying calculate future value. Calculate the future value, and put in the rate and the payment. And then for type, down here, if you scroll down, you'll see payment at the beginning, payment at the end of the period equals 0. 1 to know it's annuity due, type 1 to solve that problem. And it's the same function down here. Year, payment, and then type 1. Present value, future value use function. We have our N per, and then we have our payment. And again, this is type 1. What it's just saying is that we have the first payment goes into the beginning of, so that makes on your overall interest calculations, you have one extra use calculation. Okay. So this is the present value of annuity using annuity thing here again is that the type it's default 0, but you want it's going to be an annuity due. Let's move in rates and bids. Okay. So we want to solve for R, special rate formula to solve for R. I'm going to type in rate, and our N per here is our N per. Now, future value and present value. Future value, and then present. I have present value that this Excel likes. So hit done, we get the rate. So once again, the rate function, the N per, present value, future, to get the rate. So very simple, right? And if you keep doing this, it doesn't purge present, future value. Oops, I'm in the wrong cell. Okay, so it's a 30 because it's a big rate there. Paste it down here. Functions are all the same. Now, if we calculate solve for the number of years, a new formula, N. So if we're calculating N per, we use rate, have the present, and we have the future value. Hit done. Calculates. So pretty simple formula. Calculate for years. We have our rate, present value, and future value. Okay. To calculate this. All right. Moving on to mixed stream, we have different flows, different cash flows for the total cash flow here. So we want to calculate the present value, but I'm going to use the net present value in the Excel function to calculate this. So net present value, calculate this. Then we have our rent, and we'd have to in each value separately. Or if we didn't want to do that, in value 1, we could just highlight values straight row from year 1 to 5, each value separately. Value. So when you calculate value, you can use the future value function, net present value, value we're saying is we're going to value, and we're going to say our rate is 8, and our present value is going to calculate it above times 1. And then this will calculate future value. Now I need to put in my N per, it's missing. Okay, that's better. over here, net present value. And then I can just highlight value 5, not the total cash. Value is 5, there is no year 0 here, and done. And this will give me my present value. And then for future value, my present value will be value times -1, it's a number, and that's how we calculate total future present value of a mixture of those. Okay. Now here we're going to calculate the APR and the EAR, which is effective annual rate, is the effective annual rate. APR, annual percentage rate, which is also the nominal rate, is the same as the APR. So to calculate here, what we could if we wanted to, for the effective annual rate, we're going to use the effect formula in the builder. Again, to get full insert formula, looking for effect and the nominal rate. This is the nominal rate, and then the end period is here, which is this is another, which is 1. See that if there's a frequency annual rate always equals 8, or the APR. But if we have effective rate of 2, we put rate and we get the rate. If I pull this down, the frequency, as the frequency increases, the effective increase. Now, say for example, I had the effective but not the nominal rate. I could calculate that too, putting in nominal, and I get the nominal formula, 8, end period, done, rate as well. So you can use either calculate an effective annual rate, nominal rate, you use nominal. So you can these values down. It's the same set of problems. Now let's go continuous. So continuous compound. Here's the formula. So calculate the continuous B2, which is in value. I'm going to multiply that by the XP, which you bring into the exponent, and then B times So if we look here, we want to use the formula XP. Go here, type in EXP, and it's these. You put that in the wrong. You have to implement this. So you do this again. Just going to take this, and I'm going to hit done. Then I'm going to go into the formula, and I'm going to say this time to get the. It's a combination of two. Do this exponent, which creating E out of the formula. So to try it again, A times, and then we can insert, and we'll calculate same way. Leave the last one for you. So again, is the future value with continuous compound. Use this P to raise power to a given number, which is basically the exponent. Okay. Now let's move into our, which is interization. So here we're going to look at, I have an example of a regular, which is just going to be 4 years, and then I have a. So the key is to calculate this payment in this field. And you see I'm using these dollar signs to cells positioning. This is create one formula, copy down. So for example, if I created this formula here, then read function absolutes in the cell for end and present value, calculate the results. And then here's we're also block is the rate, applying it by E. Here is just subtracting being C8 and then plus E8. Have these calculated. I just pull this down. This is 0. Here we know my amortization schedules. What we're showing is here's my payment. This is going to be portion to interest, portion to principal, and then the total principal of year. Basically taking times the rate to calculate the interest. It's that principal. So I take my 1292. This is my remaining principal. Beginning of the loan, less interest at the end of the loan, and more principal at the end of the loan, and less principal. Since the principal balance is largest at the beginning of the loan, that's why you pay it at the beginning. So if I would want the payment function, and I'd have the rate in front of each of the variables. to lock it in. Because I want to pull this form down later. So you see here, so this present value should be by inserting these dollars, I can lock it. So this would be the value of the interest. I would take principal times the rate of interest. I want to make interest. And we'll take in the total minus the interest principal, and then the ending principal would be the beginning plus the payment to principal. And we want this just like over. We want a negative amount, so put a negative in front here. Okay, I could pull this down. See that's something. See the process of 5, not a 4-year period. I'm just going to extend this by pulling it down. I get to 5 years. That's when we get to zero balance. So that's sort of trouble when they should be. You want to look over the problem issue B. That's always key. When you're doing these value of money problems, you always want to make sure when you're calculating, does it make sense? And if you don't get an amortization schedule, you're not going to be correct. Because this is breaking down the interest paid to loan. Now, what if we do a car loan which has a bigger frequency? Here, we're going to look at $4,000 at 4% for 5 years at a frequency, monthly frequency a year. So again, calculate the total payment per year, our payment function, and our rate is going to be the rate divided our frequency, and per is going to be our year multiplied frequency. Have present value of the loan. I'm going to hit done. So this total payment. But we want to lock down some of these. So specifically on P here, we want to put some absolute around. Enter in $sign around the frequency. Thing for N per, because these are not just saying we don't want these when I call formula lower. Principal. We don't want this principal to drift. Say, lock these cells in. So when I copy this down, it's always going to be the same. Again, just like we calculated over, we want to lock a couple of cells and the balance. So basically we're going to take the interest divided by C, multiply that by that to be stable as well. We want this to be, calculate this as a negative. So how did we get here? We put a negative sign in the formula. Okay, so instead of a plus, negative. So we count this as a negative, and then we our total payment, our interest. This is the amount goal, and we net these two together. And if I have the proper absolute, none are needed here, and lock in, so these are fine. So when we write these down, it's actually, so I need to tell something here, J and J and 17, J, the can drift. So I had this in the back, so now that's going to work. Okay, and for this all the way to the bottom, 60 periods because it's 5 on, we get that 0. As long as it's pretty confident that this is going to be. So, last year 67 in interest and $404 to pay off the remaining principal. So if our loan basically $2,800 annual of 20, a total payment to 26, percentage of our payments that are interest is about 10.6%. Okay, so that's how you call it schedule. So start to make extra payments in your car in the beginning months as much as possible. That's when you're getting charged the most interest, highest principal balance. So towards the end of the loan, say your loan, it doesn't make too much sense to act off early, not paying that much interest loan. But if you look at this loan we paid, and this is double checking, it's $24,000. So at the end of the loan, the principal is our interest and our total value. This is just total for the 5 years, not average. Okay, so that's how you do loan amortization schedule. Okay, we've completed all of the problems that are in Chapter 5 of Time Value using Excel and using Formula Builder, found on the formulas and insert function. Each of these set of problems. We need a sheet to help you with any exams that have a preset that will work in solving similar. Okay, thanks for your time. Take care.